All right, now that we've learned about Euler's formula, I wanted to show you a cool thing about Euler's formula and trig identities. So I've written down Euler's formula over here. E to the ix is equal to cosine x plus I sine x. And this formula is really your key to never having to look up or remember another trig identity. So to show you how this works, I'm going to take the only trig identity that I actually remember, which is sine 2x, and that is equal to 2 times sine x times cosine x. So to prove this, I want to start with looking at e to the I2x. Now, using Euler's formula, that's going to be equal to cosine 2x plus I sine 2x. But I can also write this another way. I can write this as e to the ix times e to the ix. And I can write each of those e to the ix's in terms of Euler's formula. So I can really have cosine x plus I sine x times cosine x plus I sine x. And then I can just expand, get rid of the parentheses, and I'm going to get cosine squared x plus 2I sine x cosine x. And then when I do I sine x times I sine x, I'm going to get an I squared. And of course, I squared is going to give me -1 times sine squared x. But this still needs to be equal to that. So I'm going to have cosine 2x plus I sine 2x. And as you may remember from earlier math classes, the real part of one side of an equation has to be equal to the real part of the other side of an equation. And the same holds for the imaginary parts. So the real part of this side of the equation, which is going to be cosine squared x minus sine squared x, that has to be equal to the real part of this side of the equation, which is going to give me cosine 2x. Likewise, the imaginary part of the left-hand side, which is going to be 2 sine x cosine x, has to be equal to the imaginary part of the other side, which is going to be sine 2x. So here are two trig functions, and really that will work for anything. It'll work for the sine or cosine of a plus b, a minus b, and you can show that with just a little work on your own.